Yeah. So there are two parts in this particular interactive session, the lab session. So today we are going to discuss about synthesis method, two synthesis method. Namely, the first one solving, other one. So to a maximum extent, we are going to try to show one method, maximum second method also. Right. So because it will try to take at least half an hour, 1 hour, even more than that also. Right. So in the first part, we try to finish the experimental technique, how to synthesize the nanomaterials by soldier and then the hydrothermal. Right. So tomorrow, in class, right after your session in the seminar hall, you directly come here. So we are going to show you how to make a device. Means the supercapacitor, how to make the battery, the energy storage battery. We will try to show you, and then we will try to give you the demonstration of that particular battery, what we are going to fabricate with our material to blow, to blow the electronic gadget like LED or calculator or some sort of electronic gadget we are going to blow by means of the material which are grown by means of soil method, right? So today I will try to demonstrate the various steps which are involved in preparing the material, right? So tomorrow by using that material we are going to fabricate the device, and means battery we are going to cell, we are going to the supercapacitor cell we are going to fabricate it, and then 2 cell or 3 devices we are going to use it and blow the electronic gadget. That is the first one. And second one, we are going to give the demonstration for the hydrothermal method, and the same material we are going to use to give a demonstration how we are going to use for the wastewater treatment. Means of photocatalysis technique. We are going to eliminate the dye. So we are going to explain to you the procedure to eliminate the dye from the industrial wastewater. So we are going to use our material, right? With the help of that material, we are going to remove the dye which is present inside the polymer. Right. So we will try to explain to you the methodology, characterization, and then application, right? Which is mostly relevant to our the title of the program, right? Photocatalysis and then energy storage, right? So calculation part, Mr. Sushil will try to explain, right? And then the synthesis part, theory part she will try to explain, and the experimental part will explain both by Gangadhar as well as Sol, right? So it involves calculation. See, when you are preparing any material, whether it may be glass, ceramic or nanomaterial, so we need to do some calculation, right? Suppose you are preparing for 1 gram or 2 gram, 5 gram, 10 gram, whatever the quantity, we need to know what are the precursors you are going to use, what are the solids you are going to use, what is the pH value, right? So how much the yield you require, right? And what are the precursors? See, if you are using precursor, which chemical you are going to use? But you are not using chemical, we are using some sort of industrial based material to prepare our material for the application, right? So first part we will try to the solution, we will try to how the solution will try to form, and then we need to dry it by means of using the oven, then you need to centrifuge it, then you need to center it, and how you are going to center it, I given the temperature optimization which you are going to get by means of TGTT. So how you are going to center it, we are having the ovens, we are having the the furnaces, 1400 furnaces there, the 600 furnaces there, so that also we will try to show you. So she will try to tell you the theory, what is happening, and Gangadhar and then Saurabh will try to explain the experiment part, right? So today we try to learn, and you just try to work out for a composition. If you have any difficulty, you can ask them tomorrow. But tomorrow is exclusively application. She will explain about the device, the cell, and we will explain about the photocatalysis technique by means of this one. Is it okay? Over to you.
So, actually there are a lot of synthesis technique. You people know there are physical method, chemical method. So usually for the synthesis of nanomaterial, physical methods are there and chemical methods are there. So physical methods are those methods in which the chemical reaction is not involved. So like ball milling or solid state reaction method or laser ablation method. So like that, these are the physical methods in that no chemical reaction is involved. So known as physical method. So second one is chemical method, in that Soldier method of synthesis, hydrothermal, solvothermal, co-precipitation method, or emulsion method. There are a lot of methods involved in case of chemical. So in all these chemical process, chemical reactions are involved. So these are come under the categories of chemical process. So today we will discuss about Soldier method of synthesis. Later on we will discuss about the hydrothermal method. So in Soldier method of synthesis, basically 5 steps are involved. So first one is hydrolysis, then polycondensation, and then aging, then drying, and then calcination. So basically 5 steps are involved. First one is hydrolysis. Second one is polycondensation. Third one is aging. Fourth one is drying. And fifth one is calcination. So we'll discuss one by one. So in first step, first one is hydrolysis, means the reaction of the metal oxide with water. So usually these two fundamental reaction involve hydrolysis and polycondensation. So in hydrolysis, reaction of metal alkoxide with the water. So it will form metal hydroxide plus water. Okay. So this reaction involved. Second one is polycondensation reactions. So in that these metal hydroxide that will form a 3D network, cross interlinking of these metal oxides, and they will form metal oxygen metal bond, and there is a release of water or any alcohol compound, so removal of that, and they are forming a metal oxides. During this step, during that time, polycondensation time, gelation takes place, gel kind of formation. You will see during the demonstration time, they will show you the gel kind of things, means viscous. So at first, in the name itself, it is a Soldier method of synthesis. So Sol is actually, it is a colloidal suspension of solid particle in liquids, and gel, we are talking about gel. So gel is a 3D cross interlinking of these particles surrounded by a liquid. Means in that there is a more solid particle, means we can call it as liquid in solid. Means more is the solid part and less is the liquid part. In we can say solidification of gel. Solidification of gel means the viscosity of the gel network formed, so that viscosity is increasing. In case after that we'll put in a we'll dry it in a hot air oven. So and then further we put it for the calcination in a muffle furnace. So as sir mentioned, at first we have to do the TGDT of the dried sample, to know the crystallization temperature of the material. So basically, actually, as I mentioned in the hydrolysis, we can take water. If we take water as a solvent, so we can call it as aqueous sol-gel process. If we take other alcohol material, then we can call, means this process will change accordingly. The name of the process will change accordingly. And what amount of water is required for the solution, that will also decide the viscosity of the gel, also that interlinking of the metal oxide. So this is a theory of this process. Then my senior will tell the calculation, the molar mass calculation of this method.
Okay, so you have noted these. So what are the steps? Tell me the steps. You noted? So today we are going to prepare calcium silicate. Okay. So calcium silicate is CaSiO3. Okay. So it has two components: calcium oxide and SiO2. Okay. So by composition, they have equal mass ratio or mole ratio, you can say. Okay. So they both, when they are both in 50-50%, then they will form a calcium silicate. Okay. So what sir had told, sir, I have told you that about beta vollastonate, something like that sir has told you during the presentation. Okay. So that is only calcium silicate, because calcium silicate has different forms, but one of the forms is beta calcium, beta vollastonate. So we are going to prepare this this form of calcium silicate. Okay. So for making this, we need in what percentage we should be. Okay. So in nature they are in 50-50%. So we will take both in equal mole percent. Okay. So these are 1:1 molar ratio we will do. This is in molar ratio. Okay, that is the important point, that they are in molar ratio, not weight ratio. If they are in weight ratio, what we will do? We will take 1 gram of calcium oxide, 1 gram of silicon oxide, and then directly we will dissolve and directly mix the mixture and we will get the calcium silicate. But they are not by weight ratio, but they are by molar ratio. Okay. So for preparing 1 gram of calcium silicate, we will multiply this by their molecular weight. Okay, so molecular weight of calcium oxide is 56.0774. Okay, and the molecular weight of SiO2 is 60.0. Okay, so we will divide one by another. You can divide it by SiO2, or you can divide by the molecular weight of Ca. Okay, so I divided by molecular weight of Ca. So for 1 gram, what will the value become? 1:2. What will the value become? This X you have to calculate. Okay, so for preparing 1 gram of calcium silicate, you need 1 gram of calcium oxide and 1.075 gram of SiO2. Okay. Okay, understood? That much you understood? Okay, next. Now for performing a soil gel method, what you need to do? You need soil. Okay. So you first have to prepare the soil. Okay. So for preparing the soil, you need a solution. Okay. So what we will do, one of the amazing property of SiO2 in amorphous form, it will dissolve in NaOH. Okay. In highly basic condition. In highly basic condition, it will dissolve. At normal condition, it won't dissolve. In highly basic condition. So what we will do, we have to dissolve SiO2 with NaOH that will give us sodium silicate. Okay. Okay. Now this is a reaction. So reaction, what we have to do, it should be equivalent oxygen plus water will also get released. Okay. So here we have two sodiums. So we have to multiply it by 2. Now this equation is balanced. Okay. Understood? Okay. So now we have silicon oxide, but we don't know how much NaOH we want to dissolve. Okay, we need some exact amount using which we can dissolve this much. Okay, and we don't know how much calcium sodium silicate we need. But what we know the molecular weights. Okay, what is the molecular weight of NaOH? 39.997 is 40, and it is something molecular weight. Okay, we don't need to worry about it. We just need one with balanced chemical reaction. Okay, so now we need one thing, we know 3 things and we know 1 thing. Okay, so from here we can calculate X value. What will the value become? Calculate. 1.075 multiplied by 2 into 40 divided by 16.0. 1.431. Okay, so this is in gram. Okay, but our solution is present in liquid form. Okay, so this is not liquid, this is solid. So we need liquid. Okay. So what you can do, one thing is that you can divide it by density. Okay. Or another way is we can calculate the number of moles. Mass of molecular mass. Tell me what will the value will come. You know moles. Moles. You know what is moles? Because we need to prepare 2 molar NaOH. Okay. In this solution, we will dissolve SiO2. So we got the value of NaOH, which is in solid form, but this we need in liquid form. Okay. So we will dissolve it in water, but it should have that solution will have some strength. Okay. So that strength is 2 molar. M is for strength of the solution, molarity. So calculate what will be the number of moles of solution. What will be the number of moles of NaOH? Divide 1.431 divided by the molecular mass of NaOH. Tell me this value. 0.035. Okay. Now we need what is divided by volume, which is given in liters. Okay. This volume is generally volume of the solution we use. Okay. So we know the moles, we know the molarity, we can calculate the volume of the solution. Okay. So volume of the NaOH will come 0.035 divided by how much it will come? 0.0175. That is in liters. We convert it in milliliters, so 17.5 ml. Okay. So from this, what we got? That to dissolve 1.075 SiO2, you need 2 molar solution of NaOH. Okay. So this will be our solution A. Solution A is sodium silicate solution. Okay. You have noted this one? Now we have another component, that is calcium oxide. Okay. So calcium oxide. Can dissolve in acids like hydrochloric acid, nitric acid, HF. Okay, it can dissolve in any acid. Today we are using HCl to dissolve calcium oxide. So if calcium oxide reacts with HCl, it will give us calcium chloride, CaCl plus water. Okay, so it will be like this. Okay, again the same thing we did here. We will do the same thing. So how much HCl, 2 molar HCl we want to dissolve 1 gram of calcium oxide. Okay, so 1 gram of calcium oxide, we don't know this one, we know this value. What is the molecular weight of HCl? 37 or 33, 36.5. 36.5. Molecular weight of HCl? 36.5. This value of X you will get 1.301. Okay, now we'll calculate direct molarity. So it will be 1.301 divided by this. Volume in liters. So what will the volume of HCl? 2 molar HCl. Give me this value. 0.0178. This is in liters. So you want 17.8 ml of 2 molar HCl. 2 molar HCl to dissolve calcium oxide. 1 gram of calcium oxide. That is our solution. Okay. So this reaction, the first one will happen at an elevated temperature, starting with 70 degrees. We can increase the temperature. Then also this reaction will happen. This reaction will happen at room temperature. Okay, RT. You don't need any temperature. It will happen at room temperature. After preparing these two solutions, this solution 2, we add solution A clockwise in solution 2 until we start to form a C there. Okay. So now it will be demonstrated by Gangadhar.
पोज कर दो.
Suppose actually it was set करना पड़ेगा.
Strength of 3 molar, 4 molar, depending upon your material. This you will find from experiment. If you do experiment, then you will do. Because with this comes the value of pH. It is not because we are taking 2 molar NaOH, that's why our gel is forming. It's because using this solution we are getting that pH at which the gel will form. So sometimes it may happen that sometimes it happens that we take direct concentrated HCl, like from the bottle 36%. It is pure HCl that we get. We take that. At that time also, this sometimes we don't get the gel. So it is not a fixed formula. We got the gel at 3 molar of HCl also, 2 molar HCl also. So you can change the concentration of the solution, strength of the solution according to your situation. Because that will affect that the strength of the solution will also affect your final crystal size will also it will get affected. You can get, maybe it may happen that your morphology of the sample line changes. This can also happen. So depending upon the case, so many things work.
It can increase and decrease the strength, means speed of the reaction. If you take the higher strength solution, then your reaction will speed up. And these are the calcium oxide and silica SiO2 we extracted from the eggshell and rices.
See, this rice we have collected from the nearby factory. Okay, this rice we have collected from the nearby factory, and we have cleaned this first using sodium L'Oreal sulfate solution, which is a surfactant. Means the surface impurities, whatever is there, it will get removed. Then we have treated this with 1 molar HCl solution at 70 degrees. The previous researchers have shown that at 70 degrees we can get maximum silica out of rices. So we have used those conditions to extract SiO2. Okay, we treat it and HCl, and then we'll dry it in oven. Then we'll do calcination at 700 degrees Celsius for 5 hours. So it will turn into this white powder. Similarly, for eggshell, you have all eaten eggs at home. Okay, eggs you have eaten at home, and you are vegetarian. Okay, you have seen in TV that while they break the egg, inside some organic film is there. Okay, so what we'll do, we'll take the eggshells, we'll remove those organic films. Okay, then we'll wash it, and then we'll grind in pestle and mortar to a fine powder. Then we again we do calcination at 900 degrees Celsius, so we'll get this beautiful white powder. Okay, that we can use for our process.
So actually there are other sources also you can use, like sir mentioned, Schnell cell is also a source of calcium oxides. But majorly in the eggshell there is a higher yield of calcium oxide we are getting, that is why we are using. You can use other sources also. As for the silica also, other sources
Like you can use peanut shells, you can use
sugarcane husk
husk, you can but
husk also you can use.
okay, then coconut shell you can use. Okay, all those things contain silica, but the percentage of silica is very less in those. They around 50% or 60% or 30%, because they have mixture of some other oxides will be there. Some like peanut shell will contain 35 or 50% of silica, plus they have sodium oxide, potassium oxide also. So generally we try to use the material according to our goods. Like if we want potassium in our final product, then it is better to use peanut shell. Okay, like if you want a mixture of the things that contain iron, like industrial waste, the Puja is working with fly ash. Fly ash has good percentage of iron. So in your final material, if you want some iron percentage, then you can use fly ash. So according to your application, you have to change the waste material.
Actually, one of the major advantages why we are using these waste material, actually not only the final product we are getting that calcium oxide, CaSiO3, we will mention that. See, when we mix both the solution A and solution B, so Na2SiO3 plus CaCl2, so that final product will give you CaSiO3 plus 2 molar of NaCl. So not only that you will get in the final product when you use this waste material, except from this you can get other transition metal oxides also. Because as if you take the industrial waste material, as I am using on fly ash and GGBS, so apart from the calcium and silica source, they are having iron also, potassium also, or magnesium also, or titanium also. So that will influence the optical property. So without any external doping, we can enhance the optical property of the material also. So this is one of the major advantage of using the waste material. You can explore in other waste material, like sir mentioned that industrial waste, like nowadays people are using marble or granite waste. So marble, they reported that it is a source of calcium oxide and granite is a source of silica oxide. So you can explore in that area also.
Okay, we'll continue. Another is ready to show the experiment. Okay, you can come close.
Synthesize calcium silicate means olefstenite, beta olefstenite by Sol-gel method. So we are taking two precursors. One is rice husk gas, that is derived from the rice husk, and another one is egg cells. As my fellow scholars, they have told how to derive these egg cells and rice husk gas from the agricultural waste. So first, so all the calculations they have already told you how to do the calculations. So we need how much? So 2 ml of 2 molar of HCl, 17.6 ml to dissolve 1 gram of calcium oxide. Similarly, how much? 17.5 ml of NaOH to dissolve 1 gram of SaO2. So we have already prepared 2 molar of HCl and 2 molar of NaOH. So from this we will take 17. Okay, we will take 17.5 and 17.6. So I am measuring. First I am taking 10 mm. That bit we have already used for this. We can use it directly. And we have heated it at 80 degree will be. Okay, at 90 degrees we are heating because it needs some temperature to dissolve SiO2. Okay, at room temperature it won't dissolve. Okay. Then we'll take 2 molar of HCl. So there will form one solution, here will form another solution. So how much? This one I will clean with the water. So cleaning is important. So because if it will be any impurity, then reaction won't happen, or your product will be a different product. It won't be whatever you want it to be. This is 10 ml I have taken. How much HCl is needed? 1.2. No, not 1.2. Here below. 17.8. Okay. 7.8. This is 7.8. We are doing the same way. Okay. Can you stop that thing also? So now we'll measure the precursor. It's too much hot because of this environment. Spatula of pen taking. First we'll make this due. Okay. So it should be exactly 1 ml. Because coachability is important. So why we have turned on off the fan? Because this is highly sensitive actually. So to measure the gold, we used to use this actually. Means it is maybe more than that actually. Okay, so 1 gram we have taken. So we will dissolve it here actually. Slowly we will dissolve. Okay. You are there. Okay. Or else you just put it this way. This way. This way. Let us give me.
डाला भी नहीं डाला पानी डाला हाँ पानी डाल दिया
No, actually you have to measure appropriate amount of HCl, 2 molar of HCl.
Themselves have been prepared properly.
Otherwise it won't be there. If you
Yeah.
take less concentration of HCl solution and you add the more CO amount, that will not be.
Now
That
you
is why we are doing this much calculation. So
Yeah.
you have to take the exact amount of it. So maybe they did something. So let's see, it should turn into
No,
a transparent
सब डाल दे पूरा डाल दे
We got the transparent solution.
उसको ढक के रखो टेम्परेचर थोड़ा ज़्यादा करो टेम्परेचर इंक्रीज करो
कितना ये limit है?
90 का Anyways,
But the rate of reaction we need to give some temperature. So 70, 80, 90.
anyways क्या है ऊपर ये हाँ
See, we usually we have to give this for some time. We know temperature, then we usually require less time. That depends upon the rate of the reaction. Steering, you need only 1 hour to 2 hours steering. After that, when you mix both the solutions, then stay for 1 more hour, and then further you need to put this.
This Borosil filter paper. filter this solution. So while we are filtering if any unreacted impurity is there, we'll take it out. We'll take only the dissolved silica solutions, Na2SiO3, sodium silicate solutions will take. So both the solutions I am just filtering. We'll mix all the liquid clockwise.